In this problem, we're told the length of a rectangular dog pen is 1 foot less than twice its width. The area of the dog pen is 45 square feet. Find the width and the length of the dog pen. Use the formula A equals L times W. Well, the first thing to do in these types of problems is sketch the situation. Notice I said sketch because this does normally not look too rectangular. That's about as good as it gets. And I know the area is 45 square feet. And here's my length and here's my width. So I know area equals length times width. Notice in this equation I have 3 variables. I've got to try and reduce it down to 1. I know the area is 45, so I can write 45 equals, but on this side I've got 2 variables. So I'm going to have to write 1 in terms of the other, and that's when I use this first sentence. So let's translate it. The length of a rectangular dog pen is, translate to L equal 1 foot less than twice its width. Since it's less than, it's going to involve subtraction, and order matters with subtraction. And a lot of students just translate it exactly in the order it's written. They write 1 minus 2W. But that is incorrect. If I want 1 foot less than twice the width, I have to start with twice the width, 2W, and then subtract 1. So be very careful with less than statements. More than is fine because 2W plus 1 and 1 plus 2W, order doesn't matter in addition. So now what I'm going to do is take this statement that I just got. So instead of L, I'm going to write 2W minus 1 times W. Notice now how many variables in this equation? I only have 1. That's what I want. So I'm going to distribute in the W. So I get 45 equals 2W squared minus W. Now what type of equation is it? It's degree 2, quadratic, so I need everything on one side, 0 on the other. So I'm going to subtract 45 from both sides. So that gives me 0 on the left-hand side, and on the right-hand side, they're all unlike terms. I can't combine them, so I'm going to write them in descending order. So there's my quadratic equation, and let's look at to see if we can factor it. So let's compare it to this equation here. A is the coefficient of the W squared, so it's 2. B is the coefficient of the W term, -1, and C is the constant term of -45. So I'm going to multiply A times C, so it's 2 times -45, which is -90. So I need 2 numbers that multiply to -90 and add to B, which is -1. Since it multiplies to a negative, they're opposite in sign, and the bigger number has to be negative. So I could use 1 and -90. Those multiply to -90, but 1 plus a -90 is -89, way away from what I need. So what I'm going to do is pause it and work on the table. So I completed the table. This one didn't work, this one, and this one, but finally that one did work. So the numbers I'm looking for are 9 and a -10. Now, if when you're looking at this problem, you can immediately come up with the numbers, that's fine. I'm just showing you a table that's a systematic method that you can use when you get stuck factoring. Now remember, these two numbers aren't my factors. That's what I'm going to break my middle term down into. I'm going to write plus 9W minus 10W minus 45. And all I've done is rewrite that middle term as 9W minus 10W. The reason I did this is now I have 4 terms. How do you factor 4 terms? By grouping. What do the first two have in common? A W, and that's going to leave me with 2W plus 9. And now you bring down the middle sign, so it's a minus. What do the last two have in common? I think they have a 5 in common. Be careful when you're pulling out a negative, it's going to change the signs of both of these. Pull a negative 5 out of a negative 10W, it's going to leave 2W. Pull a negative 5 out of a negative 45, it's going to leave you plus 9. So be careful when you pull out the negative. Now, is this binomial the same as this one? Yes. So that's my common binomial factor that I pull in front. So I have 2W plus 9 is my common binomial factor. What does it leave behind? W minus 5. So now I factored my quadratic equation. Next step is you set each of them equal to 0. Because two numbers multiplied together equal 0, one of them has to be 0. So the first one, 2W equals negative 9, subtracted 9 from both sides, dividing both sides by 2. I get W equals negative 9 halves. And this one, add 5 to both sides, W equals 5. So I have two solutions. Are they both viable? Have you ever heard of a width that's a negative number? No, widths and lengths can't be negative, so that is not a viable solution for our application problem. So the width landed up being 5, and remember, what were our units? Feet. So my width was 5 feet, but also we were also asked to find the length. Remember, the length was 2W minus 1. So L is equal to 2 times 5 minus 1, which is 10 minus 1. So the length is 9 feet. So for my rectangle, the length is 9 feet and the width is 5 feet.